So, welcome to my talk about CSS3 and GWT in perfect harmony. If it works. So, my name is Julien Dramaix. I'm a software engineer at Arbis. I'm a GWT contributor and GWT maintainer. What is this about? During this presentation, I will talk about a new feature available in GWT 2.7. So, this is a new syntax for writing your CSS with CssResource, and this syntax is based on closure style sheet, or GSS. The first question maybe is why? Why not simply use pure CSS in GWT application, and why proposing an alternative syntax to the existing one? First, we need something more powerful and advanced than CSS, because with CSS, an important principle is missing. This is the dry principle, is don't repeat yourself. And so if you have a big application and you have a lot of CSS to write, your CSS files will become quickly a mess, and it will be difficult to write and maintain those files. And then the reason why we need an alternative syntax, it's until GWT 2.7, CssResource was lacking in terms of CSS3 support. That was one of the most voted issues for GWT. This is because the existing parser that was used by GWT to parse the CSS was a parser written in 19th, so it doesn't know nothing about CSS3. So we decided to use a new technology to parse our CSS in GWT, and so we choose closure style sheet or GSS. But what is closure style sheet? First, it's an extension to CSS. So that means that you will create GSS file and use the GSS syntax, and then the compiler will compile your code in plain CSS. GSS has a native support for variable, conditionals, mixin, so you will be able to respect the dry principle. You don't have to repeat a lot of code. The GSS compiler also will minify your CSS, and it will do it very aggressively. I will show you later in this presentation that you will be able to use the GSS compiler without any change in your code. And just by doing that, the size of your application will decrease just because of a better minification of your CSS. Also, the GSS compiler will validate your CSS, and it will fail if it detects error or if your CSS is invalid. It supports also right-to-left flipping, and it will rename your style class. And yeah, the big feature is it comes with a full CSS3 support. And finally, another reason on why we choose GSS is that it's an open source project, that is a project that was created by Google and is maintained by Google. So if we need to change or fix something, it's much easier. It gives us more flexibility. Just an example of what GSS looks like. We will see all the features separately later in this talk, but we define a constant, we define a mixin, we use the constant and the mixin in your CSS code. This is after the compilation, you refine pure CSS. Before to present you all the different features present in GSS, let me show you how to use it in your GWT application. Logically, first thing to do is to create a GSS file. So this is a my JSS file, my first CSS.gss. You have to create your CSSResource interface as usual. So you have to create an interface that will extend CSSResource, and then we have to create a client bundle that will give you an instance of your interface. Everything that you use with CSSResource right now works with GSS. So for example here, if the name of the method doesn't match the name of your file, you can use the @source annotation. And then you have to enable GSS. The support of GSS has been added in GWT 2.7, but it's not enabled by default. So you have to explicitly tell to the compiler to use GSS to compile your CSS. And for doing that, you have to set the configuration property name CSSResource.enableGSS to true. For UiBinder, you have also explicitly to set an attribute named GSS in your inline style. So this is an inline style that you can use in your UiBinder template. You have to add the attribute GSS equal true. This is because we will see later that when you enable GSS, you can continue to use the old syntax. So you can have a mix of the old syntax and the new one. When the compiler will see a .gss file, it will say, okay, it's GSS, I will compile it and create the CSS. But when the compiler will see a CSS file, it will try to convert in memory to GSS first and then compile it. But the problem with UiBinder is that you don't have any external file. So the compiler is not able to make a choice if it's GSS or CSS. So you have to explicitly tell to the compiler, okay, it's a GSS code. GSS will be turned by default in GWT 2.8, sorry. So the step 3 and the step 4 will not be needed anymore with GWT 2.8. So let's now review the syntax and the feature of GSS that you can use in order to write your CSS. The first feature is the ability to define a constant. So nothing new, is very similar to the existing syntax. The only difference that you have to use to define the name of the constant using uppercase. If you don't do that, the compilation will fail. The runtime evaluation, sometime you will be interested by injecting some value in your CSS that are now only at runtime. I mean, before to inject the CSS. For example, if you want to build a custom theme for your user, you will only know the color to use in your CSS when the user will use the application. And it's what we need runtime evaluation. And to do that, you can use the eval function. The eval function is the function that we had in GSS, and it take a string as parameter. The string should be any valid Java expression that returns a string. So in this case, we use static constant, but you can also call static function and so on. As we've just seen in the previous slide, so there are some built-in functions in GSS that are not present in the standard CSS that you can use in your GSS file. So this is an example. This is the add function that is present in GSS. So the compiler will add the value of the three constant and replace the call to the function with the result of the computation. And so there are different arithmetic functions that you can use to add, to subtract, to multiply, to divide, to use min, max, etc. You have also a built-in color manipulation function. So for example, if you want to adjust the brightness of a color, or if you want to create a contrasting color, and so on, you have the list there. Normally, in GSS, you are able to create your own function. In fact, the implementation of the function is done in Java, so you just have to define a class that implements a certain interface. And so you have a method where you will receive the parameter passed in the function, then you make the needed computation, and you return the resulting CSS. The problem is that you cannot do that in Grid for the time being because there is no mean to add your function to the compiler. So you cannot say to the compiler, hey, this is my new function, I want to use it, and this is the implementation to use. For the time being, it's not possible. But I should have time to add this feature for Grid 2.8, so stay tuned. The next feature I want to talk is the mixin. For me, it's the best feature of GSS. The mixin are a kind of macro. So it's a macro that takes some parameter, and you have a body that contains CSS rules. So you can use the def mixin at rule to define your mixin, and when you want to use your mixin, you use the mixin at rule. And the compiler will replace the call of your mixin by the body after replacing the parameter. So this code will compile to this. For this example, okay, we replace one line by two lines, but when we have code like this, it's to define different border radius of an element. It's better to call mixin border radius that's adding the 12 CSS line. At RBs, we have several CSS groups, and they have had the idea to create an open source project named GSS. GSS is GSS on steroid, where they gather all the mixin that you are using in your project. And let me show you. Oops. So this is the documentation of GSS. And so, for example, we have the border radius example that I just showed you. But you can different, for example, for the gradient, because for my part, I don't know how to specify a gradient in CSS. I have to go to Google to search for that. So we can use directly the mixin. So if you want to use mixin in your application, check first in this project, maybe the mixin is already existing. Oops. Yeah, and if you want to see some CSS animation done with GSS, you can visit our website in RBs. Let me show you. Oops. This is the RBs website, and all the animation that we see, it's the Grid application where we use GSS. And all the animation is done using CSS and using GSS. So, for example, this is one application I like. Or another one that's really nice. This kind of animation that we can do using CSS3 and, you know. Okay, next feature is conditional CSS. Yeah, we have two types of conditional CSS. We have what we call the compile time conditional and the runtime conditional. The compile time conditional is conditional that are evaluated at compile time. So that means that the compiler is able to evaluate the different conditions and choose which block to add in your CSS. The other is conditional that are evaluated at runtime. So that means that all the CSS go to your application. At runtime, we will choose which block to add in your CSS. Let's start with the conditional evaluated at compile time. Yeah, that's conditional based on permutation or properties that you define in your module file. In order to be able to test on the permutation value or configuration property, you can use the is function. The is function takes normally two parameters. The first is the name of the permutation that you want to test, and the second one is the value. And if you specify only one parameter, we assume that you want to test on the user agent. So if you read this code there, if we are compiling for Internet Explorer 8 or Internet Explorer 9, and the local is not English, you can use this CSS code. Otherwise, if it's Safari, you can use this CSS code. Otherwise, if a custom property I define in my grid.xml file, if this value includes this CSS, otherwise use the other CSS. Note that with GSS, you can use the boolean operator in your conditional. It was not the case with the existing syntax. Yeah, a special case for compile time conditional. If we have single boolean value configuration property defined in uppercase, that is that. It's the configuration properties with multi-value set to false, and where the value is set to true or false. If you have this kind of property, you are not obliged to use the is function, and you can test directly with the name of the configuration property. Yeah, for the conditional evaluate at runtime, we have to use the eval function, and you have to pass in as parameter any valid Java expression that will return a Boolean. The difference between runtime and compile time conditional, this code is valid. That means that you can use compile time conditional to define the different value of constant, but you cannot do that with runtime evaluation. This code is not valid and the compilation will fail, because the compiler needs to know the value of the constant at compile time. This is the same here. We can use a compile time conditional to specify the external directive. You will see this feature afterward. But you cannot do it with runtime conditional. In fact, the rule is with runtime conditional can only contain CSS rule. Let's talk about resource URL. In your client bundle, you can have several types of resources like image resource or data resource. In this example, we have 2 images and a font file. And sometimes you want to refer those resources in your CSS. So you need to know the URL to access this resource at runtime. And to do that, you can use the resource URL function. And as this function, you can assign the value of the function to a constant, or you can use directly the function in your CSS. Yeah, the alternate directive. If you try to compile this CSS with GSS, the compiler will fail. just because you define 2 times the same properties. If you remember, I said that GSS will try to detect, to validate your CSS. And in this case, it doesn't accept that you define 2 times the same rule in the same rule set. So now, if it's intentional, and in this case here, it is intentional because you are using the RGBA function and it's not supported in all browsers. So the first rule is the fallback rule if the browser doesn't support the RGBA function. You have to tell to the compiler that is intentional and that you want to keep both rules in the final CSS. And for doing that, you just have to add the alternate command in front of the second rule. GSS come with built-in right to left and left to right flipping mechanism. So if you take this CSS and when the application will be used with a left to right local, the compiler will flip automatically some property in your CSS. So that means that here the margin right will become margin left, the border left will become border right, and the padding left and padding right will be switched. So this is the CSS used by your application if you are using left to right, and it's done automatically by the compiler. That's nice. But sometimes you don't want this behavior. So for example here, I don't want that the compiler change the margin right to margin left. And if you want to avoid that, you can disable this behavior by using the no-flip annotation in command. So in this case, the compiler will not flip the margin right, but will continue to flip the border left and the padding right and padding left. The Sprite support. If you want to define Sprite, you can do it using the grid Sprite property and give between quotes the name of the image resource to use. The compiler will create the needed CSS to create the sprite. External classes, you know that the compiler will rename and obfuscate the name of your style class at the end, but sometimes you don't want that, so you want to disable this mechanism for some classes because maybe the class is used by another external JavaScript library, so you don't want to obfuscate the name of the style class. You can do it by using the external at rule, like is the case for a time being with the existing syntax. The only difference here is that you cannot use the dot in front of your class name. So if you write at external dot my legacy class, the compiler will fail. And if you want to use the star suffix, so in this case, that means that all the classes starting with grid dash will not be obfuscated. You have to use code to surround the star suffix. OK, so we are done with the list of features. So let's talk about how to migrate an existing grid application to GSS. What you have to do to convert all your existing CSS file to GSS, what you have to do is to convert all your CSS file to GSS, and to help you in this task, we have created a converter. It's a Java class named CSS to GSS. This is the help of the converter, and if you don't pass any option, the converter will expect to convert only one file and will output the result of the conversion to the standard output. Now, if you want to convert all your CSS file in your application, I recommend you to use the -r option, and then you give a directory, and the converter will recursively convert all your CSS on the given directory, and it will leave the .css file in place, but it will create a new GSS file with the result of the conversion. So this is for converting only one file, and this is for converting a directory. If we have only, for example, only one CSS file to convert, I've created also a web application. When you can pass your CSS, you click on a button and you will receive the result, the GSS, the conversion to GSS. Okay, support of the legacy. When you enable GSS, you can continue to use the old syntax. Imagine, for example, that you are using an external library that contains some CSS resources that are not using GSS syntax. You are not able to convert this file in GSS. So in this case, you can enable an automatic conversion to GSS during the compilation. That means that when the compiler will find a CSS file, it will first convert the CSS file to GSS in memory and then compile the GSS. And for doing that, you have to set the configuration property CssResource.conversion mode to strict. And yeah, each time the compiler will find a CSS file, it will automatically try to convert to GSS. There are two conversion modes, simply because GSS is stricter than the existing syntax of the existing compiler. That means that when the converter will try to convert automatically your CSS file, it will maybe detect some errors. In this case, if you are in the strict mode, it will just stop the compilation and say, okay, your existing CSS is not valid, and I'm not able to convert it to GSS. But this is the same problem. If you are using an external library and you cannot fix the CSS, you can enable the lenient mode. When you enable this mode, the converter, instead of fail the compilation, it will try to fix your CSS automatically. But let me tell you an example. With the old syntax, if you are using runtime conditional to define the variable, with the old syntax, that will work. That means the compiler will say nothing and continue. But the result is not the one that you expect. That means simply the existing compiler will just skip the runtime evaluation, and it will consider that the definition of the constant is outside of the conditional. With GSS, it's not the case. With GSS, it will fail. But if you enable the lenient mode, during the conversion, the converter will extract the definition of the constant and put the definition of the constant outside of the conditional. So you have to avoid to use the lenient mode, and you have to try to use the strict mode only and to fix all the errors that are detected by the converter. The migration path. Sorry. The first thing that you have to do is to enable GSS and enable the auto conversion in strict mode. You compile your application. You fix all the issues found by the converter and by the GSS compiler. Then, when this is done, you use the converter and convert all your CSS file to GSS, and then you set back auto conversion to off. This is the recommended migration path. Yeah, some configuration properties that are useful to know. The first one that I want to talk is the CssResource.obfuscation prefix. Let me show you it's defined. This is to specify a prefix that will be put in front of your style class after the obfuscation. If you let, that is the default configuration in the, and if you let this default configuration, each class name will be prefixed by a string of 7 characters, I think. It's very useful if you have several GWT module, GWT application working on the same page, because that avoids to have conflict between your different GWT application. But if you have only one GWT application page, I recommend you to disable the obfuscation prefix, because your class name will be shorter. And to do that, you just have to set the value to empty, and so the compiler will not add a prefix in front of your class name. And your class name will be 3 characters instead of 10. The allow at rules, GSS allow you to use only standard at rule. If you use another non-standard at rule, it will fail. But if you want to continue to do that, you can specify with this configuration property the at rule that GSS can understand. So for example, here, we want to use the -most document at rule. You have to specify it in your configuration file. Otherwise, if you use this at rule directly without these configuration properties, the compilation will fail. It's the same for the allow function. So GSS authorizes only to use the standard CSS function. If you want to use a non-standard function, so for example, imagine that in the future you have a sine or cosine function and you want to use it, you can add the name of the function that are allowed to be used in your GSS file. The roadmap. So, as I said, the GSS support has been added in GWT 2.7. It was flagged as experimental and disabled by default. In GWT 2.8, GSS support will be enabled by default, but and the old syntax will be deprecated. In GWT 3.0, we will remove the support for the old syntax, and we'll also remove the autoconverter. So don't wait, it's time to migrate to GSS, and Google did it, so most of the Google GWT applications have migrated to GSS with success. So that proves that GSS is stable, so you can migrate right now. So I finished. Thank you for your attention. And if we have questions, I think we have time. Thank you.